Okay, here's a question about the de Broglie wavelength. And I'll just be honest with you, this question seems a little esoteric to me. What is the meaning of this? So they're asking how fast must a 2.2 gram ping pong ball travel? So they're asking about the speed or the magnitude or the velocity of a ping pong ball in order to have a de Broglie wavelength that is equal to that of a photon of green light. Okay, so we have the wavelength here. Wavelength must equal 512 nanometers. And they're asking you about the speed in order to achieve a wavelength of that size. Well, first of all, the meaning of this is a little bit crazy. It's sort of the wave-particle duality, and the question is, if this were a wave, and this were its wavelength, how large would the velocity need to be? Okay, you'd have to go to your equations and recognize that this equation right here gives you the de Broglie relationship, that lambda equals h over mass times velocity. Wavelength is equal to h over mass times the velocity, and it shows u as the velocity. So we need to know a bunch of things. We know that the mass of the ping pong ball is equal to 2.2 grams. The h is equal to 6.626 times 10 to the negative 34th joules second. And by the way, I'm going to look at the answer here just to give myself a little reprieve here. The answer has 3 significant figures, so I guess I'll carry around 4 significant figures. The mass, we got the mass, we have h, and we know the lambda equals 512 nanometers. So 512 nanometers. Okay, let me just check that. 512 nanometers. Okay, good. So we're computing the velocity. So what is u? U is equal to h over lambda times n. This is sort of a plug and chug problem, but you have to be careful to make sure the units are working together. So we have 6.626 times 10 to the negative 34th joules second. Now we have to use SI units. The lambda is 512 times 10 to the minus 9 meters. That's a nanometer. And the mass, the mass is equal to the mass is equal to, we need the SI units, which are kilograms, 2.2 times 10 to the negative 3 grams. Now, if we do the math for all of this, we end up getting, let's see, joules second over meters. I'm sorry, this is supposed to be kilograms. Thank you. We should end up with meters per second, and I could show you that that is the case. We will get meters per second by, let's using a different color here. Joule is equal, this joule is equal to a kilogram meter per second squared times a meter. So we're getting rid of one of the seconds by multiplying it by the seconds. So we can rewrite them. I'll write the units down here, just so you can see how to cancel them. Kilogram meters per second squared times a meter times this second here, divided by kilograms, that's this kilogram here, divided by meters, that's this meter here. So you can see the second cancels here with one of these, the meters like this, the kilograms like this. So you get meters per second. So we get 5.88 times 10 to the negative 25th meters per second. Let's go back to our choices. Is that any of the choices? Ooh la la, here we go. 5.88 times 10 to the negative 25th. The answer is B. That is a very small velocity.